Bismillah ar-Rahman ar-Rahim. Today we are going to represent to you lecture of heat therapy and infrared radiation. First, physiological effects of heat. It increased metabolic activity, increased the blood flow in the area heated, and the stimulation of neural receptors in the skin or tissues. Factors affecting extent of tissue heating: size of the area heated, depth of absorption of a specific radiation, duration of heating, intensity of irradiation, and the methods of application. So first we are going to discuss increased metabolism or increased metabolic activity. There is a statement called Van Hoff's statement: any chemical change capable of being accelerated is accelerated by a rise of temperature. So tissue heating accelerates the chemical change. Increased metabolism is greatest in the area where most heat is produced, mainly in the superficial tissues. As a result of increased metabolism, there is increased demand for oxygen and the foodstuffs, and increase the output of waste product and the metabolite. Second, increase the blood supply to the area heated. Mechanisms by which blood supply is increased by the effect of heat. Vasodilation of the capillaries and arterioles occur as a result of increased metabolites. Heat has a direct vasodilation effect mainly on the superficial tissues receiving most of the heat. Superficial nerve ending stimulation causes reflex vasodilation in the area treated. So these are the mechanisms by which supply is increased in the area. So what is the effect of increased blood supply in the area heated? Increase the blood flow in the area so that the O2 and the nutrients are supplied and waste products are removed. Skin erythema appears as soon as the part becomes warm and fades soon after heat exposure stops. Increased pigmentation following repeated exposure to infrared. Third, effect of the heating of the nerves. Definite sedative effects. Accelerated nerve conduction by heating. Sensory excitation reaching the brain simultaneously with the pain excitation results in the pain impulse being attenuated. Second is the indirect effect of heating. Second of physiological effect of heating. So first direct effect, second is indirect effect. First on the muscle tissues. Rise in temperature induces muscle relaxation and increases the efficiency of muscle action. As the increased blood supply ensures the optimum conditions for muscle contractions. Second, in general rise of temperature. As blood passes through the tissues in which the loss of temperature has occurred, it becomes heated and carries the heat to other parts of the body. If heating is prolonged and extensive, a general rise of temperature occurs. Vasomotor center and heat regulating center in the hypothalamus are affected with generalized vasodilatation. 3. Fall of the blood pressure. Generalized vasodilatation causes reduction in the peripheral resistance and the fall in the blood pressure. Decreased blood viscosity by heating causes decreased blood pressure. 4. Increased activity of sweat glands. Reflex stimulation of the sweat glands in the area exposed to the heat, resulting from the effect of the heat on the sensory nerve endings. As the heated blood circulates throughout the body, it affects the centers concerned with the regulation of temperature with increased sweat gland activity in the body. Increased sweating results in increased elimination of waste products. So all of the last section was the physiological effect of heating or the effect of heating. we're gonna to go through infrared radiation. Infrared or IR are electromagnetic waves with wavelengths of 750 to 4000 nanometer. In general, there are two types of infrared generators are available, luminous and luminous. We start by non-luminous. There is no lumen, non-luminous generators. It is a coil of fire wound on a circle or a cylinder of an insulating material such as fire clay or porcelain. An electric current is passed through the wire and produces heat. Infrared rays are emitted from the hot wire and from the fire clay, which is heated by combustion. Some generators have the wire embedded in a black fire clay. The emission of rays is from the fire clay. The element is placed on the focal point of a gently curved superficial spherical reflector, which is adjusted as required. A third type of non-luminous generator consists of a steel tube, within it a spiral of wire embedded, and some electrical insulator, which is a good heat conductor. Current is passed through the central wire and produces heat, which is conducted by the insulator to the steel tube, which emits infrared. Tube is bent into 2 or 3 turns and mounted on a suitable reflector to give more heat. All non-luminous generators or elements require some time to heat up before the emission of rays reaches maximum intensity. It requires from 5 to 15 minutes. Lamps must therefore be switched on an appropriate time before they are required. Our guard is present to prevent inadvertent contact with the lamp. Non-luminous generators produce infrareds with a wavelength 750 to 15,000 nanometer, with the maximum emission in the region of 4,000. This is an example of non-luminous generator. Here is there is no another example of non-luminous generator. Then we shift to luminous generators, which is frequently around in our PT departments. The lamp consists of wire filament enclosed in a glass bulb, which is evacuated. The filament is a coil of fine wire and is made of tungsten, which tolerates repeated heating and cooling. Air exclusion prevents oxidation of the filament, causing opaque deposits inside the bulb. Current passage through the filament produces infrareds, visible and few ultraviolet rays. Front of the bulb is red to filter out the shorter visible and ultraviolet rays. Spectrum is from 350 to 4000 nanometer and maximum radiation at the area of 1000. This is the infrared lamps, which is luminous, which all of us know it by its different shapes. We shift to techniques of infrared treatment. How to make a session of infrared. First, choice of the apparatus. In acute inflammation or recent injury, the sedative effect of rays of non-luminous generator is more effective for pain relief than the counter-irritant effect of those from the luminous source. In chronic lesion, the counter-irritant effect of the shorter rays emitted from the luminous generator is chosen. So this is the choice of. Select the generator most suitable for the area to be treated. If only one surface of the body requires irradiation, luminous generator is preferred. If several aspects requires treatment, non-luminous generator is chosen. Before use, the lamp is checked to ensure that it is working correctly. Non-luminous generators must be switched on an adequate time before use, as mentioned before. So this is the first choice of the apparatus. Second, preparation of the patient. Clothing is removed from the affected part. Skin sensation to heat and cold is tested. Defective stimulation is defective sensation is a contraindication to infrared because the patient cannot conceive heating and this results in a burn. Patient is advised that he should experience a comfortable warmth. He should inform therapist for overheating, which may cause a burn. Patient should be comfortable and fully supported so that he does not move unduly during treatment. Third is arrangement of the lamp and the patient. So we choose the lamp, I would choose the infrared generator, then preparation of the patient, then arrangement of lamp and the patient. How the lamp is applied to the patient. The lamp is positioned so that it is opposite the center of the area to be treated, and the rays strike the skin at the right angle, thus ensuring maximum absorption. Distance of the lamp from the patient should be measured. It is usually 50 to 75 centimeters according to the output of the generator. Face should not be exposed to infrared. Eyes should be shielded if it is not possible to avoid face irradiation, like what happened in the facial palsy. Now we shift to application of infrared. At least infrared exposure, the intensity of irradiation should be low, but after 5 to 10 minutes, when vasodilatation occurred and establishment of increased blood flow, the strength of irradiation must be increased, moving the lamp nearer or adjusting the resistance. If they becomes extensive or excessive, the therapist should reduce the intensity of infrared and encouraging sweating by water intake. At the end of exposure, skin should be red. No sudden rise after extensive exposure. No go to cold immediately. Number 5, duration and the frequency of treatment. So we choose the apparatus, we prepare the patient, we adjust the lamp and the patient together, and then the mechanism or the treatment session itself. Then number 5, duration and the frequency of treatment. We are still in the mechanism or the how to give infrared session. Acute inflammation and recent injury. Short exposure of around 10 minutes is adequate and may be applied several times during the day. Longer and infrequent exposure is used for chronic condition. So all of the last 5 steps or 5 points are related to the mechanism of giving infrared radiation. Choice of the apparatus, preparation of the patient, adjustment of the lamp to the patient, mechanism of infrared application, and finally duration and the frequency of the session. We shift to another point, which is therapeutic uses of infrared. Relief of pain. Mild heating produces pain relief through the sedative effect of the superficial sensory nerve endings. Strong heating irritates the superficial sensory nerve ending, so pain relief by counter irritation. Relief of pain also happens via increased blood flow through the pain treated, removing metabolites and pain producing substances. Muscle relaxation produces pain relief. Mild and short time heating is required for acute inflammation. Chronic inflammation needs stronger heating and a longer duration of around 30 minutes. Second, muscle relaxation. Muscle relax most readily when the tissues are warm. Pain relief facilitates muscle relaxation. Infrared is of value to relax muscles associated with acute injury or inflammation. As infrared produces pain relief and muscle relaxation, it is usually applied preliminary to other forms of PT. After infrared, movement of the part is done through a greater range and exercise can be performed more efficiently. Third, increase the blood supply. This is marked in superficial tissues and may be used in the treatment of superficial wounds and infections. This promotes healing, and increased white blood cells number and fluid exudation, which destroys bacteria. Heating of superficial structures like a small hand and the feet joint, if inflamed, causes vasodilation, increases the blood supply of the O2 and the foodstuffs, with removal of the pain-producing substances and waste products, help in resolution of inflammation. Then we shift to another area of the session of the subject, which is the dangers of infrared radiation. Dangers. First, burns. Infrared radiation can cause superficial heat burns. A red patch is seen on the skin, which subsequently blisters, caused by too great an intensity of treatment. This occurs if patient, and what are the circumstances under which burns may happen in the session of infrared. Patient does not understand nature of treatment, so he become more near to the lamp, fails to report overheating, moves nearer to the lamp, fall asleep during treatment, and so also overheating happen. Defective skin sensation, so that the patient is unable to appreciate the degree of heating. No adequate time to give is given for non-luminal generators to warm up before placing in position, results in overheating. Also, use of alignment render the skin hypersensitive, so increase the danger of burns. Impaired blood flow due to pressure or some circulatory defect, with increased risk of overheating as the heat is not carried away from the area as readily as usual. Burn also happen as a result of touching the lamp when it is hot. Overheating of carelessly placed pillows or blankets may happen. The burn must be kept clean and dry and protected with a dry sterile drain. So first of the danger of infrared radiation is the burn. Second is electrical shock. Rare occasion of touching exposed part of the electric circuit, this resulting in electric gangrene. How gangrene happen in the session or at the complication or the danger of infrared. Heat accelerates chemical change, including metabolic process in the tissue, so increasing the O2 demand. This is done via increased blood flow. If blood flow is defective, O2 demand is not met and the gangrene is liable to occur. Infrared should never be applied directly to an area of impaired arterial blood supply for that risk. Then headache may follow infrared, especially if sweating does not occur or if the treatment is given in hot weather. Encourage water intake during treatment session to induce sweating. Avoid exposure or extensive infrared in a very hot weather. Avoid irradiation of the back of the head to avoid headache. Faintness. Extensive infrared radiation is accompanied by a fall in the blood pressure, which may result in a faintness due to brain hypoxia. This happens mainly if the patient rises suddenly from the recumbent position after an extensive treatment. Eye injury. Eye exposure to infrared may predispose to cataract and conjunctivitis. Eye should be protected from infrared radiation. Then we shift to contraindications of infrared radiation. First, defective arterial blood supply to the area to be heated. Areas of risk of hemorrhage. Areas of defective skin sensation. Areas of recent application of liniment or cream. And thank you. Take care that all point or all sections of the lecture can be come in the written questions, like contraindication of infrared, like indications of the circumstance which needs infrared, like danger is the same as contraindication, like how to apply infrared to the patient, the section of mechanism of application of infrared, physiological effect of heating. This is contraindication of infrared, so take care, all of that can come in the questions. Thank you very much.